Hello, welcome back to GroundhogGrafix. In this video, I want to cover the Tiny C compiler, TCC. First thing you're going to want to do is go to the website if you don't have it installed, and you're going to want, and I'll have that link down below in the description, or you can look up Tiny C compiler on Google, and it should pop up as your first option. You go down here to the download link, and we have several options here. So a lot of these are older versions, and I think you probably want to go with the latest version. So I went with Win64. You could go with Win32, whichever one you need for your operating system. And I went down here. BusyBox is some sort of like a Linux emulator shell. I'm using Cygwin, so I don't need this, but if you want it, I mean, it's here. And there's also the Win API. If you want to do some Windows programming, this will have some of your Windows libraries and stuff in it, I think. So I've downloaded this and I have installed it in my include folder for TCC as well, but I haven't done a lot of Windows programming, mostly just consoles, so I don't really know exactly what all it offers, but I'm sure it offers quite a bit. So one of the first things we're going to want to do after you've unpacked this, I'm not going to go through it, of course, you already probably know how to do it if you're a programmer, right? So you unpack this to whatever folder you want on your computer, and then we want to set up our environment variables. So we will go to Windows key X, and we will go to System, Advanced System Settings, Environment Variables, and in our path statement, we'll edit that. And you see right here, I have it on my D drive. You might have it on your C drive, TCC. So that's okay. Oh, if you wanted to add it, you would just click New, and then you would add D:TCC, but I already have it, so I'm not doing it. Cancel that. Oh, nope, go back. Now we have a couple more variables that are also important. These are environment variables that TCC will look for. And I have them down here in my system variables. Oh no, I don't have them in my system variables on here. I actually have them in my Cygwin. But if I wanted to, I would go new, and the variable name would be, let's see, capital C underscore include path. And then I would come down here and I'd put like D:/TCC slash include, although TCC will already look at its own include folder, so you don't have to actually put it in the environment variable. But if you have a project folder where you have your own includes, you might want to add this as an include path, or for some library or something, you're going to need this include path. And also, what we would do is, for our libraries, we would put library path, and do the same thing with the variable value of wherever you have your library path. Also, one more thing too, with the C include path, I believe you can also do C path. I haven't done it, but I think that's an option too if you want to shorten it. And that's how you set up your system variables, at least in Windows. If I go to cancel out of this, I'll show you in Cygwin. Okay, now I'm in Cygwin, so I would go to my root folder system and LA list all, and you would have a .bash RC file. Well, I have actually added, you can add your environment variables in your .bash RC file if you want, but I have made a separate environment variable file, which is .bash underscore env, and I actually call that file from my bash RC just to keep it more organized. So if I want to, I go to ed, which is an alias for nano, and I will put .bash env. And if we come down the list of my exports, I have TCC path variables, C include path, and notice I do not list it like you would in Cygwin. I list it like I would in DOS. I don't put like cygdrive /D. I just put D:, because TCC doesn't know anything about Cygwin and how it stores it. It won't understand it. So this is just for TCC. So I put a D:, and you can put the /. You could do /, but then you would have to do //, like an escape character for the / to be accepted. So it's easier just to do a / for TCC. And like I say, I have export for C include path. I have export from my library path. So now TCC will also search these directories for includes and library files. Down here I have some other compiler switches. I added these before I did my system variables. So I was using these on the command line. The dash I, capital I, is for an include directory, and the dash capital L is for my library directory. But now that I have the path variables, this is obsolete. So now we've gone over all of our system variables and everything. I guess we can get started on compiling and some of the TCC options. Okay, so now what I'm going to do is I'm going to go to my D drive. I'm going to make a directory. I'm going to call it test, cd test, and I'm going to go edit, which is actually an alias for nano. And I'll put ed, and I'm going to put test.c, and I'll write up a little include stdio.h and main. And we'll put in puts this works. And now I will hit Control S, Control X to exit, and now we can test it out. Okay, so to compile a program, we can do TCC, and we can go test.c. Now we go list it. There's test.exe. Remove a.out. Yes. Okay, so now we got test.exe. Now, optionally, with TCC, we can also compile and run it. TCC-run test.c. And see, it says this works. And we run test. Oh, dollars. And now we have to put a period and a /test. And then it says this works. The period and /, that's for Sigwin here. You may not have to do that in your shell environment. Now, if you want to get some information from TCC, like some help, just write TCC, and it lists a whole bunch of options that you can go through at your leisure. And we can do a TCC-HH will actually give us a secondary help file or help listing, which would be some more options that you can also go through at your leisure. And if we want to, this is handy, if you want to see what the search directories are for TCC, you can go TCC-VV. And it lists all the include directories that it goes through and checks for includes. And you see it has my GroundhogGrafix include in there because of the path variable. And the library is the same thing. It also has its own paths that it checks. And these are all the paths that it will be checking for your for includes and libraries. So that's kind of handy if you need to know. Now, optionally too, if I didn't want to create an executable file, I could do a TCC dash C, which is be like compile only, test.c. And then if I list it, we got a test.o, which we did not have before, which I can show you. Remove test.o, L, it's gone, and we go up here, go TCC, and we go L, and now we have our test.o. So that's how you can make your object files if you want to. So now let's say I want to add something to this. So let's go, I'm going to use a different editor. Let's go cd test.c. This is be Notepad++. Okay, so this works, and what I could do is go new and put another one in here. So include stdio.h, and let's call this print 100. and make it take character string str. And I could go ahead and do int a equals 0, a less than 100, a plus plus. Put string. Oop, nope, don't need that. str. Okay, and we could make this a function that we could actually call from our test C file. So let me do a control S to save this. And we will do print 100.c. And if I go back to test.c and I want to do the print 100, print 100, and we'll put compiled with TCC. And we can save this. Now I will close this and hopefully we'll be bug free. So we can go ahead and go TCC and I'll go print, oh, I do a -c, print 100.c. And I could do a TCC and I could do test.c, print 100.o. Oops, one second, let me edit that. cd test.c. Forgot to put in the declaration for it. Okay, so we need to put in, did we have a return on it? I don't think I did. No, I did not put a return. Let's go ahead and put a void return. Control S, save that. And go here and we will do void print 100 character str. There. Now, hopefully TCC will be happy with that. And close this. And let's do T. Let's just go up right there. Ah, and it did. So now if we go and we do, let's try a run. Let's go ahead and put a run in here. So dash run. Well, and now it doesn't like it. Let's see. Test. ./test. That's weird because it compiled it right before and then it doesn't run it. Interesting. Let's try this again. Let's put the run afterward. Let's see. Maybe we shouldn't have put the run right before. Dash run. There, that worked better. Okay, so sometimes it can be a little finicky on where you place the parameter on the command line. But you can see right there that it works. Go up, see, this works, and then right here. So now, let's go ahead and start working with the idea of libraries. So I'm going to make another function, so we have something to put in our library. And I'm going to go CED for my notepad, and I'm going to put in a function name. Let's say function func2 dot c. Want to create? Yes. So we do include stdio.h, and I'll put void p message character str. Actually, you know what? We'll just make this void too. Void, and I will put string. This is func2 semicolon. Control S, save that. I will go to test. And I'll put void message or p message. void there, and I will put in p message like that, and hopefully we will have an error-free compile. And let's see. So now what I could do is I could do, let's say tcc-c, and I could put wildcard.c. And that'll turn every C file, it'll output an O file. There we go. So we got all of our O files for print 0 and function 2 0, or function 2.0, I mean, for object file. So now let's create a library. Let's go tcc-ar, and we could do an asterisk.o. So let me remove one object file. Remove test.o. Yeah, because we don't want that in our library. So I could do now is tcc-ar asterisk.o. Oh, but I should go as a file name. So let's call it libtest.a. So yeah, whenever you make a library, make sure you start it with lib and end it with the .a. Because it's going to be like GCC. If you're familiar with GCC, that's the same thing. TCC kind of covers or copies a lot of what GCC has for options. So now we should have a library. And let me see. Yep, libtest.a. So now let's compile test.c, remove test.exe, and let's tcc test.c, and I'm going to do a -L with a period. This would be for the directory that we're currently working in. If we don't do this, it won't find it. So let me show you. And we will put test.a. Or no, I'm sorry. -L test, and that's it. Okay, so watch this. It won't find it. Okay, see, not found. So tcc test.c -L with a dot in Cygwin. That would be our directory for our test folder right here where we have our library. -L is for a library path. And then we will do a -L test, and that's it. We don't put the lib and we don't put the .a. See, now it works. It linked it against our library. So now if I run test, there we go. Now it used our library that we made. So that worked. That's cool. All right, so we've gone over how to make libraries, how to make object files with TinyC compiler. Here's another thing we could have done to also make things real simple. Let's remove test.exe, and we could do test or tcc test. Actually, I'm sorry, tcc *c. That's just wildcard for every C file that's in this directory. And we could do a -run. And let's see if it just compiles it all and runs it. And it does. So that's also an option too. If you don't want to make the library file and the rest of it, just compile every C file in your directory and it'll link it together and it'll run it. Okay, so there's one more thing I should add here is, let's see, L. What do we come up with for an exe? Okay, so when we did the run, it didn't produce an exe. So let's try that. Right here, run, and it doesn't produce an exe file for us. So what we could also do is tcc *c without the run, but we'll have another issue potentially. Let's see what the name of our exe file is. It's func2.exe. Well, maybe that's not what we want to name our program, right? So remove func2.exe. So here's, oh no. Yeah. Okay. So here's how we could name our file as well. tcc-o test.exe *c. So the -o is for the output file name. So if we go ahead and do that, and we list, Then instead of a func2.exe, we have a test.exe. Test.exe. And there we go. And it works. So that's it. That concludes this video. Thanks for watching. Bye.